Hello and welcome back to Cracking the Cryptic, and today I get to have another go at Richard Stolk and his Sudoku variant series. The Sudoku Professor, as we know him, has been producing hundreds of different variants. He's well over 300 now. Actually, he may be heading for 400. Sorry, I don't even know, but this is one of those. Logic Masters Germany reports the difficulty somewhere 3 stars, but tending towards 4, so probably crunchy, but hopefully not impossible. And I'll have a look at that in a moment. Now, first of all, I do want to mention our apps. As always, they are available on the App Store, Android and Steam, and of course, all the extra content on Patreon, including, for those who subscribe, the $3 subscribers get to see a video of this month's January reward solve now. But also there is the puzzle hunt, and Reverend's puzzle hunt has been continuing to get correct answers ever since it was launched. And today we are crediting Luke Smallman, who said that his feelings were much as the final message, his feelings towards Reverend were much as the final message was, which a lot of people have been saying. Amanda Gouveia, Carsten and Marcus Schaefer's, Martin de Vries, Alina and Nanook, Barry Osborne, the whole Chase family. I love the idea of a family sitting down together and solving this. Brian Scott, Louise Mitchell, Kelvin Graham, and Alistair Carey. So well done to them and to Reverend. Now, this puzzle is Y sums. Now, this is a new idea. I've never heard of this before. Richard credits Mi and Ming with the inspiration behind the idea, but I think he often says that when it's his own idea and he's just thought of it while solving someone else's puzzle. So I don't know if that is, I think it's derivative rather than a copy of the rule set. Anyway, this rule set is very new, so listen up. Normal Sudoku rules apply, and clues outside the grid indicate the sum of the first Y digits from that side, where Y is the Xth digit from that side and X is the first digit from that side. What does that mean? Okay, let's try and work out what it means. So X is the first digit from that side. So let's say there was a 7 there. And we're looking at this 13 clue. The first digit it sees is the 7. And what the rule is saying is that the 7th digit in the column tells you how many of the first few digits to add up to get to 13. So you might have a 2 there and a 6 there, and that would obey this rule. So that would say, look at the 7th digit, it's a 2, add the first 2 digits, you add 7 and 6, and you get 13. Okay, well, I understand it for a worked example. It's going to be very hard to apply, I imagine, and I'm not sure we'll get our head around this very quickly. But do give it a try on the link below the video. I'm going to try it now. Let's get cracking. And I mean, I haven't got a clue how to start. What on earth? I suppose if the first Y digits equal 33, then some group of digits down here equal 12 at the other end, because 1 to 9 adds up to 45. So there might be 2, 3, or 4 digits adding up to 12. Oh, we've got some columns, okay, with clues either end. So here, the first 4, 5, 6, or 7 digits add up to 30. But the first 2, 3, or 4 add up to, or 5 add up to 16. Now the point about that is that 30 and 16 add up to 46, and they're counting something twice because that's more than 45. What they're counting twice is 1, so that's clearly only 1 cell. So this is either adding 6 cells and this one 4, or 5 and 5, that might be possible in this variant. Could even be 7 and 3. Oh, I see, this next column also has an overlap of 1 because 26 and 20 add up to 46. And 13 and 31 No, they don't add up to 46. They add up to 44. They have an underlap of 1. They have a gap of 1 between them. How are all those ones, this is it, how are all those ones going to fit into the central box? Well, they're not, only one of them is. So we have to try and find a way to get one of these ones into box 2 and one of them into box 8, because each of column 4, 5 and 6 has to have a 1 in. So there is no way to put a 1 up in these overlaps. So there must be an underlap, and it must be here. These two add up to 13, then the 1, this slot adds up to 31, and that makes the whole column add up to 45. Right, and there is no way that this is an overlap, because those two would have to add up to 19. So this has to be the overlap in column 4. Or rather, how can you force one of these ones out of box 5 is the question. So these add up to 15, and with that 16. These add up to 29, and with that 30. Then there's a 1 in the central column, which is an overlap as well. It can't be here because 4 digits including that 1 can't add up to 26, so it must be in one of these two cells. Okay, well that's a conclusion reached anyway. Now, these two add up to 15, so they're either 9, 6 or 8, 7. Oh, but, okay, if they're an 8, then we would need to have a 3, because this is adding 3 cells in the 8th cell. If they're a 7, we'd have a 3 there. If they're a 9, we would have a 3 here. But that 3 would need to put a 7 there. Well, that will work. And if it's a 6, there's a 3 there. Ah, but okay, whatever's looking from this end needs to see a 7. So if that's a 7, this would have to be an 8. And that's not possible because this would also have to be an 8 for the sum down here. So it's not 7 here. Now, can it be 7 at the end? This would be a 9. You'd have 7 here. And then you'd have to have 3 here, because you're looking at the 7th cell from the bottom to add the 3. That would work. Okay, so I can't rule that out. And that's probably about as far as I can go for now with that column. I don't see how I can work the rest out. Let's have a look at, well, this one we don't even know where the 1 is, but in this one we're adding 2 cells. So whatever that number is, we look that number of cells down and find a 2. That's not very helpful. This lot add up to 12, so they're either 3, 9, 4, 8 or no, they don't. They add up to 13. Sorry. 4, 9, 5, 8 or 7, 6. This lot have we're adding 6 cells to make the 31. I don't know what that means we can do. I don't know. I'm going to have to look at other clues now. That's irritating. Well, let's look at these. I mean, 11 and 5 opposite each other do not look very promising. What about the 5, though? Can it be... Oh, I see. It can never really be a 1 in this cell, because that would tell you to add the first cell. Only if the clue was a 1 could you have a 1 in the first cell. But you could be adding 1 or 2 cells. You can still be adding 1 cell. So if there was a 9 here and a 1... Oh, then you don't get 5. Ah, I see. Yes, okay, sorry. So you could start with the digit in the clue if the 5th digit can be a 1, but it can't here because we've ruled it out of there. So we are not adding 1 cell, we are adding 2 cells. Now, can they be a 2-3 pair that we're adding? Then they can't, because if that was a 2, that would need to be a 2, because we'd be adding 2 cells. If that was a 3, that would need to be a 2, and neither of those ways will work. So this is a 1-4 pair, and it doesn't start with a 1, it starts with a 4, and the fourth cell says add 2 cells. So there we go, that does it. Now what about this 11? Now this cannot, yes, how many cells are we adding? Not 1, because 1 cell can't make 11, knowledge bomb time. Not 3 or 4. 4 cells would need 1, 2, 3, 5, clearly we can't do that. 3 cells would need either a 1 or a 2. 3 plus 5 plus 6 is the minimum you could go now, and that is 14. That's far too many. So we need to be adding 2 cells. So this cell needs to tell us to look for the 2. We add the 2 cells, we get 6 and 5. Wow! So we can do something with some of these. Now what about this 7 clue? We're either adding 1, 2 or 3 cells. So you could have a 7 in this cell and a 1 in that one, but you can't have a 1 in that one. So now we're adding 2 or 3 cells. If we're adding 2 cells, then there is a 2 in one of the first 6 cells, because these two have to add up to 7, so they both have to be less than 7. And 2 can only appear in the first, second or third cell. 2 there would need a 2 there, that's nonsense. 2 there would need a 3 here. Oh yeah, that would work. 3, 4, 2. The 3 tells you look in that cell, that tells you add the first 2 cells, and now they're 3 and 4. So that's possible. But could we be adding only 2 cells in some other way? If there was, oh, we could be adding 3 cells. That's the other possibility. 4, 2 and 1. But it needs to tell us to add 3 cells. So we'd have a 4 here. A 4 here, a 2, 1 pair here, and a 3 here. And that is possible. Okay, so those are the only candidates there. I'm not leaving the 3 in as a candidate there because it's not the only one. Wow, that is so confusing to get your head around this. Let's keep looking though, because these clues are helping. This 6, it's either adding 1, 2 or 3 cells. If it was 1, we'd have a 6 here and a 1 here, and we can't do that. So if it's adding 2 cells, well, it can only do it by, given this positioning of 1 and 4, it would either be 2, 4, but that would say add the first 4 cells, or it would be 1, 5, but that would say add 1 cell. So it's not in 2 cells. So it's adding up 3 cells, which are therefore 1, 2, 3. The number here can't be 1. If it was a 2, yes, that works. If it was a 3, it would say add up the number. No, hang on. If it was a 2, it's saying add up the number of cells there, and that couldn't, oh yeah, that could be 3. 2, 3, 1, that works. If that's a 3, what does that mean? That means, oh, that doesn't work, because that means you need a 3 there. So this is a 2. This must be a 3 and a 1 by Sudoku, and that does work. That 2 is saying look in the second cell, and that's saying add the first 3 cells, and you get 6. This is so complicated. 1 up there. It is doing my head in. There's a 1 down there by Sudoku. I'd like to get this to the point where I could be doing Sudoku rather than working out every one of these clues, but Richard doesn't put clues in unnecessarily, so that's not going to happen. Right, let's have a look at this 13. Now, we could be adding 2, 3 or 4 cells, and that's going to mean this is very hard to disambiguate. Now, if we were adding 2, there's 3 possibilities. If we were adding 3, there's lots. And if we were adding 4, there's still a few. I don't see how we can use this clue at this time at all. What about this 9? Well, this time it could be a 1 cell clue. You put a 9 in there, 1 there, that's fine. Otherwise, there are variants of 2 and 3. Again, how the heck do you get any traction on this? Ah, this 13 though. This might have opened up a little bit now. Let's have a think about this. Oh, look, yes, we can't put numbers as small as 1, 2, or 3 in these yellow cells. So the 13 is, and we can't be adding up 2 cells. We're either adding up 3 or 4, but I don't think there's a way to add up 4. The minimum for these two is 4 and 5. The minimum for this is 3. No, we're definitely adding up 3 cells here. So these two add up to 12. They're either 8 and 4 or 5 and 7. And that means the number 3 appears in either the 4th, 5th, 7th or 8th cell, and I don't have a clue which one. I have one tiny clue there. I hope someone's going to get that door right. The one tiny clue is that this can't be a 3 actually, because this set of is either 3, 4, 2 or a 4 there with a 3 there. So that is not a 3, so this can't be a 5. And that can't be a 7. I mean, that is not really significantly helping. Oh, I don't know, this 33, that looks terrifying. 17, oh, 17. Oh, okay, what's interesting here is it can't be a 5 cell clue because it doesn't have a 1 in it. Can it be 4, 2, 4, 5, 6? Darn, it can just be 4. The 4 would be in the run, so it would actually have to go 2, 4, and then a 5, 6 pair. 9 and 8? Oh, actually, yes, 9, 8, and a 2. No, that doesn't work. Okay, so 2, 4, and then a 5, 6 pair. That's the 4 cell variant. The 3 cell variant, these 3 would add to 17. They'd have to start with an 8 to give the 3 clue. These two would have to add up to 9, not using 8, 1, or 3. So 5, 4, or 2, 7. So I'm taking that out because they're not the only options. If we had the 3 cell variant, that could be anything. But that comes down to either 2 or 8. It's not that useful, but it might be something. I don't know. Now, let's have another look then at these central clues. Maybe something's happened. 6 there, for instance. That would just need a 3 here. 9 there needs a 3 here. 7 there needs a 3 here. They're all possible. Nothing has changed. That's very irritating. Come on, think, Mark, think. What about this 20 clue? I don't know. Is there something going on there? This 13? Oh. Oh yeah, we've got a 2 here. Oh my goodness, I'm so sorry. Right, that 2 is vital for this 13 clue because we know we're adding 2 cells. This is an underlap, so we're adding those 2 and those 6. So the 2 cells is there in the 4th cell, so that's a 4. Right, okay, that stops this being a 4. We aren't getting some things limited now. Down here, we're looking for a 6 in either the 3rd or 5th position because 6, 7, 8, 9 are all gone. So that's a 3 or a 5. And the 6 is either there or there. I'm going to pencil mark it just in the hope that I remember I'm looking across a box. Now, 2 and 4 have to appear in these cells. Just by Sudoku. 20. Can it now be a 4 cell 20? Yeah, I think it can, irritatingly. It could still be 2495 or 2486. If it's a 5 cell 20, it's got 2, 4 and 1 in it, but then again it just needs another 13. Ah, it's nearly there, isn't it? What about this 30? Oh, this has changed a bit because of this 4-9. Yes, I think it has. So here we are looking for the 7 in the column, but we've got to begin now with, can it be a 9 there? 7, 8, and then a 3 here. Yes, I think it still can. No, obviously it can't be a 9 here, so that's not 7. So that's a 6-9 pair, and that means this can't be 6. So now we can put 6 in there. This is now a 5 to find that 6. We've got 3, 8, 7 to place. Oh, intriguing break-in. Right, now we're looking for a 3 in either the 6th or the 9th position. But if that's a 3, then we have to have a 7 there. Oh, we can do that. This, in fact, can't be looking beyond here, so, and it can't be 1 or 4. So it could be 2, 3, 5 or 6, finding a 7 in any one of those cells. Oh, look at this now. This can't be 2, 4, 6, 8 as a 4 cell 20, because 6 must be appearing here somewhere. Actually, that can't be 6, sorry. 6 is appearing there somewhere. What I was seeing was 6 in those two boxes. It can't be 2, 4, 6, 8. It can't be 2, 4, 5, 9 either, because you can't get either of a 5 or a 9 into this box. So this is not a 4 cell clue. This is a 5 cell clue. This is a 5 cell clue. Both of these ends are looking for the 5 digit wherever it appears. Now maybe we can play both ends off against the middle and find out where that 5 is. It's clearly not in these cells because of that 5. So this can't be 1, 2 or 3. Because of the box, it can't be 5, 6 or 9. It's 4, 7 or 8. Those are these cells. So this has to be 2, 3 or 6 to match that. And these 5 cells have to add to 20. And these 5 to 26. Now they contain a 1, a 2 and a 4. That is 7 already. So the other 2 digits add up to 13. They're not 4, 9 because we've already got a 4. They're not 6, 7 because we can't get a 6 in there. They're 5, 8. This is 1, 2, 4, 5, 8. So the first 3 are 2, 4, 8. Then we have a 1, 5 pair. The 1 is the overlap in the middle. Actually, I should have done that immediately. I knew it was 5 at each end. So we're looking for that 5 with a 4 here and a 6 here. That doesn't change that, but it takes 6 out of there. That's a 2, 8 pair. The 8 is not there. 8 is now here in column 6. 9 is here in box 5. We've got a 4, 3, 7 triple here. That's not a 4. This is a 3, 7 pair. We can fill them in thanks to the 3 we did earlier. 2, 8 and 5 as a pair at the top. Ah, and 3 cannot be here anymore. So this is not a 9. 6, 9, 3 is there. Oh, and that is progress. Right, 8 and 7 to go in column, in row 4. I'm just seeing a 7, 8 pair into column 7 that I probably can't use yet. Let's take out that 3 pencil mark. Right, and we've got a 1 in the center, so there is no way that this is adding 4, 2, 1. It's adding 3 and 4 with a 2 there. That fixes the 7, 4 pair. 5, 8, 9 are a triple there. That fixes the 7, which fixes the 8. 1, 7, 9 there. 2, 3, 6 here. That can't be a 3, that can't be a 2. Right, now we are cooking with some gas. Sorry, cooking with gas is the official phrase. Now, let's look at this 13 again. This is finding a 3 in either cell 7 or 8. So there's a 3 up here now. 3 there and 3 there means 3 in one of those two cells. Ooh, what about this 9? I'm dodging this 33 clue. I'll look at the 9 and the 13 next. What about this 9 clue? Now, this is saying, again, we can put 9 there and 1 there if we're adding 1. If we're adding 2 cells, it's either 2, 7 or 1, 8 that we're adding. So it could go 8, 1, 2. Yeah, 2, 7 won't work. So it's either 1, 8 or 9. If it's 3 cells we're adding, I don't think we can, because 6, 4 and 5 have all gone. Yeah, that's not going to work. So it's either a 1, 8 pair to begin the row, or a 9 to begin the row and a 1 at the end of it. Oh, okay. I wish I knew what that was. Do we know more about this 17? Not really. Or do we? Ah, if we put, yes, no, if we put 8 there, that's still fine. That's saying add 3 cells, which is quite likely right. If we have a 2 there, we need a 4 here. 5, 6. And that still works too. Frustrating. So let's have a look at the 33. If I must now, well, it can't start with a 1 because that would tell it to add 1 square. It's either adding 5, 6 or 7 cells. So add, there's 12 after it. I don't know. I mean, this can be a 2, 3, 7, 8 or 9 here. I don't know. I don't know how to use that. That by Sudoku is either 6 or 8. Yeah, so you could use a 2 there with a 6 there. And it easily, I would have thought, get to 33. Okay, I don't think I can use that yet. I need to find one more thing somewhere that, maybe it's somewhere I've looked and I thought I'd resolved the clue. That's always possible. Oh, this 13, I was going to look at this, wasn't I? Now, we can't put a 4 there. In fact, yeah, maybe that's the way to look at it. What can we actually put here? 2, 4, 5, 7, 8 or 9. Now that's quite a fair number of possibilities, but we're either adding 2, 3 or 4 cells. If we're adding 2, then the 2 that we need to find has to be in the 4th, 5th, 7th, 8th or 9th cells. Well, there are some there where it can go, so that's annoying. If we were adding, if we were adding a 3 cells, I know that 3 is confined to those 2, so we'd have to start with a 6 or a 7. We'd have to start with a 7, putting a 3 there, and that ruins that cell, so we're not adding 3 cells. If we were adding 4 cells, this slot adds to 12, which are 2, 3, 7 or 2, 4, 6, or 3, 4, 5. Oh, do they have to use the 4 that we have to find? I don't know. I think there are still possibilities here. That is, maybe I just need to do some Sudoku. Is that what we need to do now to get going? Oh no, look, yes. 7 is looking at an 8. I'm so sorry. You've been shouting that for ages. I've finally seen it. Right, 8 there needs to be a 3 there. That resolves where the 3 is. So that cannot be adding 3 cells because it would need a 6 there. Good grief, and we can't have a 6 there. So it is doing either 2 or 4 cells. Anyway, finish off with this 8. Sorry, pay attention. Right. I'm talking to myself, of course. 2 or 9 there, that's not 3. In fact, it can be anything that the column allows. 8, 1, 4, 3, 2. One of these is a, oh look, 2, 6 pair there now. Right, 3 there. One still down here. Now, let's have another look at this. So 2 is possible if these two sum to 13 and they're picking up the 2 from outside there in either cell 5, 5, 8, 2, that works. Cell 7, 7, 6, 2, can't be cell 8 because it would go 8, 5, 2, and that 5 is impossible. And can it be 4 cells? Ah, the 3 has gone. So it would have to be 2, 4, 6 here. If that was, one of those would have to point to the 4. It would have to be the 2, but the 4 would have to be there. Wow, so it is definitely adding up 2 cells, and it's doing it either by going 5, 8 or 7, 6. That must be right. And this can't be a 2 anymore. The 2 has to be in one of those 2 cells. I've got a 6, 8 pair in the column, which I don't know, that might be interesting because we're either, I don't know how many cells we're adding yet. We're not adding 5 cells because that's not a 4 leading to that 5. And we're not adding 4 cells because that's not a 5 leading to that 4. So we're either adding 6 or 7 cells. Where can we find the 6 or the 7 in the column? 2 there, 6 there. Then we'd be adding 6 cells. We've already got a total of 17. These would have to add to, these 2 would have to add to 16. They'd have to be 9 and 7. That does look very possible. A 3 there could leave, well, it can't be a 6 or 8 there now. It could put us, we could put a 7 there. 10, 19, 33 already. No. A 7 there would tell us maybe to add 6. Oh, this is so confusing. 7. I don't know. I just don't know if we can do that. I'm going to come back to that clue again because it's driving me bonkers now. Sorry, this is hard to finish. I mean, I can see why it's 3 stars, but that kind of assumes you can get your head around it. Now, did I work out that couldn't be a 3? I think I did, because this would have to be a 7. That is quite interesting, because it means this is a 1, 3 pair. In fact, I can place the 3 there, and 1 there, 1 there. This can't be a 1 anymore. So for this to be adding 2 cells, it has to go 8, 1, 2, 9 there, and now there's nowhere to put a 3. In fact, the 3 in the row has been decided by the 3 we just placed at the top of the grid. So that becomes a 3. This can't be an 8 anymore. This is now a 9. We can put 1 in there. We've just got 2 more 1s to place in the grid at all. Ah, that 9 has sorted out these. That 17 clue is going to get resolved now. That is adding 3. So, and this can't be 2, 7 anymore. So it's a 5, 4 pair. Wow, right. That is now 9. That's sorted out that triple. This pair has been sorted out by the 2. This has been resolved. It's a 9. Just want to make sure I get it right at this point. 7 and 6 go in there. 5 and 9 up here. This is a head wrecker. 7 and 6, I can place them. Oh, I've still got this one to sort out. Can I do it now? 5 could pick up the 2 with an 8 there. 7 is not picking up a 2. Yeah, so 5 and 8, they are resolved. 2, 8, the 5, 4 here are done. 6 here, we've got a 1, 4, 2 to place. Bit of a chocolate teapot triple at the moment, annoyingly. And then we've got this 33 clue to resolve finally. So, well, we can do it by working out what's outies, effectively. 11 are not in it, so that must be a 1. We're adding 6 cells, which requires either a 2 or a 3 there, so it's a 2 there and a 6 there. That must work. Yeah, that's the 7-9 pair left that we thought we were getting. 1 there. 4 and 2 are resolved. This is a 5, 8. This is now 5. Yes, we can do row 1. Surely we can do row 3 now. 9, 7, 8. And I think we are just finishing off there. What a tricky puzzle that is. I mean, it's hard to get your head around that. I have to say, I enjoyed that. I don't necessarily want to be doing another Y sums puzzle soon because it's so confusing going, what's the 4th cell? It's a 2. Add the first 2 cells, they make 13. But there we go. Let's click the check button and done for the puzzle. Thank you very much to Richard Stolt. Very intriguing logic there. I hope you did have a go at it and enjoyed the logic if you did. If you followed the solve, you're probably thinking, what is up with that guy? And I'm sorry about missing that 7-8 pair, looking at that 8 for so long. Anyway, thanks for watching. Hope to see you again soon on the channel, and goodbye for now.